Welcome to Yantra Technologies. In this present video, we are going to learn how to interface the ultrasonic distance sensor with this Arduino and print the distances on the LCD screen. We are connecting this trigger and echo pins of the ultrasonic sensor to the pins D6 and D7. D6 and D7 on Arduino are getting connected to the trigger and echo pins respectively. If you want to change and if you want to use a different pins, remove these jumper caps and put female to male connectors to the respective pins on the Arduino Nano. And LCD is anyway, it is I2C LCD. By default, it is connected to the A4, A5 pins, which are the serial clock and serial data and serial clock pins on Arduino Nano. It is an I2C LCD, so only two pins will be required to post the data on this LCD. Now let us see the sketch. In the folder provided to you, there is a third program named obstacle. So if you click on this, it will open the ultrasonic sensor which is being interfaced to this. Basically, ultrasonic sensor works on the simple principle: transmitter and receiver. One ultrasonic transducer is going to emit 40 kHz pulses which will travel towards any obstacle, and they get reflected back, echoed back, and are detected by this receiver. So if the transmitter sends 8 40 kHz pulses, and any of the pulse, if it gets reflected back after the transmission of the last pulse, the time duration for which the ultrasonic pulse is in transit is measured by the echo pin. What I mean is, echo pin will remain at a high position until it is detected by this sensor. So whatever time it remains at high, and if at all any pulse is detected by this echo receiver, echo pin will be automatically get low. So the duration for which the echo pin is at high position tells us the time of flight of this ultrasonic wave. As ultrasonics travel with 340 meter per second speed, that is the speed of sound, so we can calculate what is the distance traveled between the ultrasonic sensor and the obstacle. So this is explained in the code. So we are using the trigger pin 6, echo pin 7, and I2C LCD instance constructor, and then we are using serial communication also. Pins are declared as input and output. Trigger is actually output. We are going to fire it, and this ultrasonic sensor's trigger pin, it actually requires exactly 10 microseconds or more high pulse on its pin. So on the trigger pin of this ultrasonic sensor, if you give a 10 microsecond or more high pulse, that is 5 volt or 3.3 volt, it will just fire the 40 kilohertz pulses, 8 pulses, and then it will wait for the echo. So trigger is something like a gun's trigger, and for this ultrasonic sensor, it is going to trigger ultrasonic pulses, bursts, and echo pin will be anyway input for this Arduino. LCD net, if at all it throws any error, you please change it to LCD begin, all small letters, and backlight, set cursor, print distance. So initially it prints the name distance, and then it will go for the loop. In the loop, we are going to set the trigger pin low to make sure that it is initially low, and later we'll once again set it for high for 10 microseconds, delay microseconds, and then we'll once again set it for low. So it is trigger pulse. You are just firing the trigger to send the ultrasonic pulses, and the duration is a long double variable where you are using the pulse in. Pulse in actually returns the time in microseconds for which this pin is either at high or low. So here we have typed high. So this function returns how much time the echo pin is at high in microseconds. So duration will be in microseconds, and distance is actually calculated using the formula distance equal to velocity into time. Here the distance is traveled twice, 2 times by the ultrasonic wave. That's why there is a 2 in the denominator, and this 29.1 is the conversion factor. Actually we are using microseconds, and 330 meter per second or 340 meter per second speed of sound can be converted into centimeters. Ultimately this distance function is going to return the distance in centimeters. And LCD clear to make sure everything is cleared, and we are once again putting the cursor at 0 0 and then printing the distance, and then going to the 10th character in the first line, and we are printing the distance there in centimeters. And also it is an obstacle sensor, so we are putting a rough distance of 15 centimeter. If at all the distance is less than 15 centimeter, then once again LCD is going to get cleared, and the cursor is going to be set in the first line, and it is going to print obstacle detected. Remember that D is not really missing. Only we can accommodate 16 characters in a line. That's why we have removed this D. It is not a typographic mistake. Intentionally it is done. and 𝒙CD.𝒤𝒂𝒅 second line, and D at, that detected the missing D is printed here in the second line at LCD print distance. So we are going to print the distance that we have obtained in the previous case, and once again we are going to print the centimeter. So if there is an obstacle, it is going to print obstacle, otherwise it will just print the distance. And the distance is calculated for every 500 milliseconds, that is every half second. So just upload the code, and also make sure that you have connected the correct board, processor and COM. So in my case COM7 is there. So let me upload the code and see what happens. See here, still it is showing the temperature and humidity. Don't get confused that the board is not working. Actually it is still printing the old ones, and unless you turn off the power, it is not going to remove the display. Now the program got uploaded. See, it is now appearing distance in 17 centimeter. I think you can see when I am pushing my camera closer and closer, see it is printing the obstacle detected, and when I am above this 15 centimeter, it is automatically printing only the distance. So obstacle detected at 14 centimeter, right? Thank you.